Hello guys, welcome to this session. Our topic is formula bonding and nomenclature. We're still discussing about the empirical and the molecular formula. So far in our previous video, we're discussing about the empirical formula. So today, let's move on to the molecular formula. Discussing about this molecular formula, first we have already seen the meaning of the molecular formula. So the molecular formula is just more useful than the empirical formula because it gives more information or more details of the compound. Now, for some molecular compounds, both the formulas are the same. We are talking about the empirical and the molecular formula. For some, these molecular compounds, they are the same, while for the others, they are different. Now, simply in order to find the molecular formula of the unknown compound, you need to know the following. First one, the empirical formula, and the second one, the molecular weight of the compound. Now, once you have these two pieces of information or details, you can now work out the molecular formula. Now let's see the examples. We'll start with the example one. A compound contains 85.7% carbon and 14.3% hydrogen. Its molecular weight is 28. So what's its molecular formula? Now solution, the first step is just find the empirical formula of the compound. We know that as usual, as normal, we have to undergo the following steps in finding the empirical formula. First, enlist the various elements that are within the compound. Here we have carbon and hydrogen, the relative atomic masses. We have carbon that is 12 and hydrogen that is 1. The percentage composition of the carbon is 85.7, while that of hydrogen is 14.3. Now the mole ratio is by taking the percentage composition, you divide by the relative atomic masses. So 85.7 you divide by 12, you get 7.02, while in that of hydrogen 14.3 you divide by 1, you get 14.3. Now, the relative mole ratio is simply by taking the mole ratio divided by the smallest ratio among of the two. So 7.02 you divide by the 7.02, you get 1, while that of hydrogen will be 14.3, you divide by 7.02, you get 2. Therefore, you have the empirical formula that is CH2. Now, in second step, that is find the molecular formula. Simply so the molecular formula is simply you take the empirical formula multiplied by the n equals to the molecular weight that which you are given, that is 28. So as the relative atomic masses, for the hydrogen it will be 12, while that of for the carbon it will be 12, while that of hydrogen it will be 1 multiplied by the 2, then you get 2, then in bracket n is equal to 28. So 14, n is equal to 28. You make n the subject by dividing 14 both sides, so n is equal to 2. So you substitute this value of n within the empirical formula, so you get the molecular formula that is C2H4. So far is mostly likely equal to the empirical formula if you simply simplify this molecular formula. I hope it's clear. Moving on, let's see the second example. A compound contains 43.4% sodium, 11.3% carbon, and 45.3% oxygen. You are required to find the empirical formula of the compound. And second one, if its molecular weight is 106, calculate its molecular weight. Now, simply we'll start with the first one. Solution. First, you have to find the empirical formula as it was noted within our example. So our first activity is just find the empirical formula of the compound. So solution, you list all the various elements that are found within the compound. The elements, there is sodium, carbon, and oxygen. So the atomic weight, as you can see here, sodium, carbon, and oxygen. Now, the atomic weight of each, the sodium is 23, carbon is 12, and oxygen is 16. Percentage composition, as it was given within the example, sodium is 43.4, while that of carbon is 11.3, and that of oxygen is 45.3. Mole ratio, simply taking the percentage composition divided by the atomic weights. So 43.4 you divide by 23 equals to 1.89 for the sodium. For the carbon, 11.3 divided by 12, that equals to 0.94. And that of oxygen, 45.3 you divide by 16, that is equal to 2.8. Now the mole ratio simply will be equal to 1.89 you divide by 0.94, that is the smallest ratio among all of the elements. So For here, for the sodium, it will be equal to 2. Then for the carbon, 0.94 divided by 0.94 will be equal to 1. And that of oxygen, 2.8 divided by 0.94 equals to 3. Therefore, you have the empirical formula. So the empirical formula of the compound is simply Na2CO3. So that's the empirical formula. Now, using that, you can move on to solving the molecular formula. Now use the molecular weight to find the molecular formula. Thus, it will be equal to Na2 CO3 in bracket N equals to 106. Simply substitute the values of the relative atomic masses. So, but for the sodium, it will be equal to 2 multiplied by 13, then plus the carbon, that is 12, that of oxygen is 3, we multiply by 16 in bracket N is equal to 106. So after calculating here the total, you get that is 106 N, that is equal to 106 N, 106 also. So divided by 106, 106, so the value of N is 1. Therefore, the molecular weight, the molecular formula is the same as the empirical formula, that is Na2CO3. I hope it's clear with this example. Moving on. So yes, in some cases the molecular weights are given, while the others the vapor density is given. So you have to note that in some of the problems. Now to get the molecular weight, simply multiply the vapor density by 2. Take an example. The molecular weight will be equal to vapor density times 2. So that you have to note it. And here's the example. A hydrogen has a vapor density of 15 and it contains 20% by mass of hydrogen. Calculate the formula of the hydrocarbon. Now solution, if hydrogen is equal to 20%, then just noticeably carbon will be equal to 80%. Now use these values to find the relative number of moles of the atoms present. So from there, so just as usual, here's our table element. We have carbon and hydrogen percentage composition. That is, for the carbon will be 80 and that of hydrogen will be 20. The atomic weights we know is 12 and 1. The mole ratio, we know that you take the atomic weight divided by the percentage composition. You take the percentage composition, you divide by the atomic weight. So 80, you divide by 12, you get 6.67. While for the hydrogen, 20, you divide by 1, that is equal to 20. Now, relative mole ratio simply will be equal to 6.61, you divide by the smallest, that is 6.61, will be equal to 1, while for the hydrogen, 20, you divide by 6.67, will be approximately equal to 3. Now, the empirical formula simply will be equal to CH3. Now, the molar mass, we know that equals to vapor density times 2. So 15 times 2, that is equal to 30, as we've said before in the previous slide. Now, from there, the molecular weight we say is 30. So from there, you can simply calculate the molecular formula as it is given here. CH3 in bracket N is equal to 30. Substitute the values of the relative atomic masses relating to the molecules. So 12 plus 3 times 1 in bracket N is equal to 30. So 15N is equal to 30. So the value of N is 2. Now that value of N is substitute to the value of the empirical formula. Therefore, the molecular formula is C2H6. So I hope it's clear, guys. Thank you for listening. We've discussed the molecular formula. We've seen how it is can be calculated. We've seen 3 vivid solved examples. I hope it's clear all these 3 examples. Thank you and see you in the next video.